Hi friends, in this video let us solve MOSFET based questions. Right, so before watching this video, kindly go to all the basics that I have put in video number 1 to 10. Then it will be easy for you, right? We need theory to solve the problems. So let us start. The question is, when the gate to source voltage of a MOSFET with a threshold voltage of 400 millivolt, working in saturation is 900 millivolt. The drain current is observed to be 1 milliampere. Neglecting the channel with modulation effect and assuming that MOSFET is operating at saturation, the drain current for an applied VGS of 1400 millivolt. So what they have given? They have given VGS and VGS of a MOSFET with the threshold voltage 400 millivolt. So they have given VT is equal to 400 millivolt, VGS is equal to 900 millivolt. At that time, ID is equal to 1 milliampere. Neglect channel with modulation and assuming that MOSFET in saturation. MOSFET in saturation. Okay. Then they are telling that what is drain current? What is ID when VGS is equal to 1400? So that is what they are asking. So we know MOSFET in saturation. So MOSFET in saturation means ID is the drain current is given by K into VGS minus VT square. This is a drain current in saturation mode, right? So for first one, let us take, this is the condition number 1, this is the condition number 2. For first one, drain current ID1 is equal to, it is 1 milliampere, that is equal to K. VGS is 900 minus VT is, they have given 400, right? Similarly for 2, we have to find ID2, which is equal to K VGS 1400 minus VT 400 square. So this is 1, this is 2. Divide 1 by 2. 1 divided by 2 is given by 1 milliamps by ID2. That is equal to KK will be cancelled. In numerator 500 square, in denominator 1000 square. So if you simplify, what you get is ID2 is equal to 4 milliamps. Right? So the answer is option B. The second question is, the drain of a N-channel MOSFET is shorted to the gate. Drain and the gate are shorted. That is VGS is equal to VDS. Right? The threshold voltage of a MOSFET is 1 volt. Drain current is 1 milliampere. For VGS is equal to 2. What they are asking is, for VGS is equal to 3, what is ID? Right? If the drain current is 1 milliampere for VGS equal to 2, what is ID for VGS equal to 3? You see, they have given drain and the gate are shorted. We know for MOSFET to be in saturation, VDS must be greater than VGS minus VT. Right, from the condition given here, you see VDS, instead of VGS I substitute VDS minus VT. So you see, surely VDS must be greater than VDS minus VT, because let us say it is 5 volt, means it is 5 minus some value, surely it is less than 5. So VDS is always greater than VDS minus VT. So the given MOSFET in saturation. Right, so that is what we understand. So MOSFET in saturation means ID is given by K into VGS minus VT square. Okay, so the first condition ID1 they have given. ID1 for first one, ID is 1 milliampere. 1 milliampere. What is VGS minus VT? VGS is 2 volt, VT is 1 volt. So 2 minus 1 square. Right, second one ID2 VDD2, that's what we have to find, K into VGS minus VT. VGS is 3 volt. Let K be as it is. K into 3 minus 1 square. Let us check equation number 1. Equation number 2. We will divide 1 by 2. 1 by 2 means 1 by ID2. It is equal to 1 square by 2 squared. So ID2 is equal to 4 milliamps because it is 1 milliamps. So ID is 4 milliampere. So the answer is 4 milliampere. Next problem is, in the circuit shown, both the enhancement mode NMOS transistor have the following characteristics. What they are given, Kn is equal to 1 milliampere per volt squared. VTN, threshold voltage, is 1 volt. Assume channel length modulation is 0 and body is shorted to source. The minimum supply voltage VDD required to ensure that the MOSFET operates in saturation. M1 operates in saturation. So minimum amount of VDD required to make M1 to be in saturation. So minimum VDD for saturation. For saturation, the condition is, we know VDS is greater than or equal to VGS minus VT. So M1, we want to find the minimum VDD. So minimum condition is equal. So VDS1. This is transistor 1, so I put VDS1. Minimum means equal. Somewhat greater means greater value. So VGS1 minus VT. Right? So from this we understand from the diagram, source is 0. That is VS0. So I can write VD1 equal to VG1 minus VT. Because VDS1 is nothing but VD1 minus VS1. So VS0, so VD1 only. Similarly, VG1 minus VS1, it is 0. So VG1 they have given, it is 2 volt. VT in the problem they have given, threshold voltage is 1 volt. So it is 1 volt. Is it okay? So VD1 is 1 volt. This we have to find. So VD1 is 1 volt means here it is a drain terminal. Here it is 1 volt. This is we have found for minimum saturation condition, right? So VG we found, VD we know. Sorry, VG given, VD we found, VS0. Now we find what is the drain current, because M1 in saturation. ID1 is equal to K into VGS1 minus VT square. K 1 milliampere per volt square. VGS1 2 minus 1 square, so it is 1 milliampere. ID1 is equal to 1 milliampere. ID1 they have given. ID1 1 milliampere. This is in series, so ID1 is equal to ID2. Right? So because both are MOS into series, so drain current will be same. So now we will find what is ID2. ID2 is given by K into VGS2 minus VT2, right? So K is, we know, 1 milliampere per volt square, and VGS2 means VG2 minus VS2 minus VT square. So it is 1 milliampere per volt square. VG2 minus VS2. VG2 I don't know. VG gate voltage of M2 I don't know. But you see, it is VS2. VS2 is equal to VD1. So VD1 we found. This both the terminals are same. It is source. So source voltage of second transistor is equal to drain voltage of first transistor. So VS2 is equal to 1 volt. So VG2 minus 1, VT is given 1 volt. That is what ID2. We know ID2 is equal to ID1, so that is equal to 1 milliampere. If you simplify this, VG2 is equal to 3 volt. VG2 3 volt, but question is VDD. What they ask in the question is minimum VDD, but VG2 we found it is 3 volt. VG 3 volt means VD2, it is also 3 volt. Both are under the same potential, so VDD is 3. So the answer is 3 volt. I hope I understand all the three problems. If you have any doubt, please ask me in comment section. Thank you.